That's great, David. So we're ready to start now to actually discuss climate change itself. So I thought we'd start with what is all this about? What do we mean by climate change, and what are we understanding by it today?
Wow.
It's a big question, but a basic introduction to that would be very helpful.
Well, one of the tasks I got into, partly by accident, was to review the text of the last Intergovernmental Panel on Climate Change.
Mm-hmm.
The main scientific report was about 1,500 pages and 3,000 references, and I had to do it twice. So my learning curve in climate change kind of went vertical. So I'll share a little bit of what I've found out.
Yes.
What we mean by climate is not what we mean by weather, first of all.
Yeah.
Climate has to do with very long-term trends in the behaviour of the planet as a whole, and some of the regional consequences of that. Whether, the temperature can go up and down by 10, 15 degrees between day to day, as it has in the last 24 hours here, or 40 degrees in a day, as it does in some desert areas. And we can move weather patterns from year to year. There's a lot of noise in weather.
Yeah.
Climate has to do with long-term trends. That's the first thing I think we need.
Yeah.
So what changes it? Well, the basic we have to know is that the climate is governed by the energy from the sun, that we receive as light energy, shortwave, and the amount of energy we send back out into space, which is heat energy, or infrared, it's long wave energy. And for climate to be stable, those two amounts have to balance each other. So energy in is balanced by energy out. When that happens, the world, what we call the global temperature, stays pretty stable. If that energy balance is disturbed, then we have problems. So for instance, if the sun increases the amount of energy that it gives us, but we go on radiating the same amount, then we go into heating mode. If, on the other hand, solar energy decreases, we go on radiating the same amount, we're in cooling mode. So the climate will go up and down, over millions of years. What's happened now is that the output of our use of yesterday's energy, the fossil energy, coal, oil, gas, as we burn it, it gives off carbon dioxide, which is an invisible gas, so we ignore it. But what carbon dioxide does in the atmosphere is that it acts a little bit like the panes of glass in a greenhouse, which allows light energy through to the inside of the greenhouse and blocks heat energy going back out, so it keeps the greenhouse warmer. It's what we call the greenhouse effect. And the more carbon dioxide there is in the atmosphere, the more it traps heat near the surface of the Earth. So it doesn't radiate that energy back to space. So that means we go into imbalance. We are now receiving more energy from the sun than we are giving back out into space. And that energy goes into what we call global heating. It increases the amount of energy available at the surface of the Earth. So the greenhouse effect from our use of fossil energy has created global heating.
So that sounds like a more accurate way of describing it than sometimes the terms used like climate change or
global warming.
Global warming.
I mean, global warming is about temperature, isn't it?
Yes.
And everybody goes, oh, who cares if it goes up half a degree?
Yeah.
Actually, global heating, if we're out of balance,
Yes.
that energy is coming in, it melts ice,
Yes.
it goes mixing into deep ocean, it evaporates water, we get more water vapour in the atmosphere, and that also, of course, is a greenhouse gas and makes the problem worse.
Yes.
So I think if we think of the heating imbalance that we have created
Yes.
by an inappropriate use of energy
Right.
source, is probably what we need to talk about when we're dealing with climate change.
Yep.
Now, to start with, of course, in the Industrial Revolution, we just used little bits of coal and so on.
Yeah.
And it increased, but it was insignificant in terms of the global scale. As we discovered oil, and then our use of that went absolutely hyper-exponential. It went off massively.
Right.
The population increased massively because we had lots of resources, lots of energy, lots of food.
Yeah.
And our use of energy went exponential. And incidentally, our production of greenhouse gases went exponential too. And now it's very significant.
And of course economic activity goes up with population and cheap energy.
Cheap energy drives the growth in economics. And then we become dependent on that growth, and woe betide us if we try to stop it, even if it means not solving the problem of the energy imbalance. So we'll get onto that a bit later, I think.
But you're showing how the different
I'm
bits
trying to show
work
how the bits
together.
they all link together.
Yeah.
Economics, energy,
Yeah.
pollution,
Yeah.
climate change,
Yeah.
consumerism,
Population.
addiction to growth,
Yeah.
population. They're all part of a complex, massive system, which is
Yeah.
the impact of humanity on a
Right.
limited planetary environment.
Right, I think we'll pause there.